Hi, everybody. So Dan introduced this project a little bit, so I'm going to jump right in pretty fast here. But as you can see, it's a big collaborative effort from the CALDER team. So we're looking at this thing we're calling academic mobility, and Dan kind of already described it a little bit. So we're not looking at this is not geographic mobility, which is what folks usually think of in education when they think of mobility. This is the extent to which students' ranks in the distribution of academic performance change as they go through school. And then, Dan gave the anchoring way of thinking about it. So on the one hand, we know that kids' longer-term outcomes are strongly tied to their earlier grade outcomes, and there's lots of evidence of that from lots of different places. On the other hand, the anchoring isn't perfect, and you'll see we have some estimates of how heavily things are anchored. And we know that school and teacher quality impacts student outcomes, and so there is the potential for the school system to alter students' trajectories. And so this project is just at a high level trying to help us better understand what happens to kids as they move through the school system. I think this work connects strongly to understanding the evolution of achievement gaps during K-12 education, because we're going to be able to track kids we're going to start with them in 3rd grade and all the way through high school and just see what happens to them as they go through school. And we know little about how much variation exists across individual school districts in terms of the academic mobility of students. So what are we going to do? We're going to take the 6 CALDER states so far, soon to be 7. We're going to use the administrative data panels to document and understand academic mobility in each state. So the states are listed right there that are in the study already: Massachusetts, Michigan, Missouri, Oregon, Texas, and Washington. In each state, we're going to take 2 to 4 cohorts of students, just whatever the data would really allow us to do. The cohorts are going to be set based on 3rd grade. These are kids who go into 3rd grade in the state public education system and have a math and English language arts test. And then we're going to follow them through, and we're going to look at their academic mobility in terms of 4 later educational outcomes. So I'll talk about these more later on, but just very briefly, we're going to check mobility in 8th grade based on test performance on the state assessments in math and English language arts. We're going to use a high school test, and then we're going to have 2 graduation outcomes: on time and then within 1 year of on time. What we're doing here is we're applying a recently developed framework in the literature on intergenerational economic mobility to study this intragenerational academic mobility. So we're following the same kids, but the tools are very similar, and I'll describe those in a minute. And just a quick plug, pat on the back for CALDER. So I think this is a good example of the kind of thing that CALDER can do and do well in terms of the scale of this project. So this project, 6 state administrative records from 6 states. We have over 2.5 million students covered by this. We're able to track them from 3rd grade all the way through high school, and for the most part, our data are pretty clean on that front. And we were able to do this all in about a year. So I'm the one who's the Missouri team is kind of coordinating all of this, and so we're getting all of the results in from all the sites and just watching all the results come in. Sometimes it's kind of impressive that we could pull this together so fast. So it was 1 year, an exhausting year, but 1 year. Okay. All right. Okay, so now I want to preview the findings, and there's 2 things I want to talk about before I actually get to the actual findings. I think it's useful at this juncture to quickly define 2 types of academic mobility from a district perspective, and this is loosely following Shetty, Hendren, Klein, and Sayers. We're deviating in the terminology a little bit. I'm not sure that was the best. That was my. If you don't like that, that was my call. We may change that back, but at a high level, you can think about total academic mobility as the extent to which a kid, say initially low achieving kids, moves up in the distribution of performance as they go through school. You can break that into 2. At the district level, there are 2 components that are going to drive that. One is what you might call, what we're going to call absolute mobility, and you can just loosely think of that as a rising tide lifting all boats. And so there's some districts that are good with all kids. They're also good with their low performing kids, and when their kids are mapped against the full distribution in the state, they're going to start growing compared to everybody else because the district is helping them along with everybody else in the district. And then there's this other concept, relative mobility, and that's more about, say, you can just think of like a within district achievement gap. And so a district with high relative mobility, say is going to help their low performers are going to be gaining on their high performers over the course of the schooling career. So a high relative mobility district has narrowing achievement gaps within the district over the course of the schooling career. Relative mobility has an ambiguous normative interpretation. And so the reason I want to mention that is just so you could have high relative mobility in a district, say, that's just not good with their top performers. So you could, and even if they're not good with their low performers, they're just bad with their top performers, and we might not think that's a good thing. And so there's a little bit of ambiguity in interpreting cross-district differences and relative mobility and whether we're happy about that or not. Absolute mobility, I think we can agree is a good thing when everyone's doing better. Okay, and so I'll elaborate on that more, but I wanted to give these basic concepts right now just because some of the results, I think one of the more interesting things we find is related to this split. Okay, and then the other quick thing I want to say before I start talking through the results, we do this for all the states, and what I'm going to show you is results that are essentially sample averages for the states. The results are strikingly similar across the states, especially, and I'll have a slide on this too, when you consider how different the states are along many dimensions. And so what I'm going to show you is the results on average across the states. All of the state-by-state stuff is in the appendix to the paper if folks are interested in that. Okay, so big picture findings. The first thing we do is we look at total academic mobility for different types of students using the traditional splits that researchers and folks have looked at, racial ethnic splits. We have free lunch and non-free lunch eligible students. This is all pre-community eligibility provision. And then by urbanicity. And our findings here are pretty similar to what other folks have looked at this kind of stuff, not in this academic mobility framework. And our findings mostly are consistent with what other folks have found. We find that especially Asian students and also white students have higher academic mobility than Black and Hispanic students. Students who are not eligible for free and reduced price lunch have higher academic mobility than students who are eligible. And students from suburban and rural areas have higher academic mobility than students from urban areas. The urbanicity gaps are much smaller. I will say there's no evidence that rural students, say, in any meaningful way, have lower mobility than suburban students. Urban students have lower mobility, especially in terms of high school graduation. But those splits aren't as important. Okay, so then, so I think that's mostly just showing things that other folks have shown in this different framework. I think the new thing we add here is looking across districts for variance in academic mobility, just answering the question: are there meaningful differences across districts in the academic mobility of students? We do find statistically significant and educationally meaningful variance in academic mobility in all of the states. So, and then the sub bullet there, one thing by decomposing where mobility is coming from, we can show that the cross-district variance is mostly driven by variance in absolute mobility, not relative mobility. So I think that's telling about how school systems might help initially low-achieving kids. But I should give the caveat here that that none of this is causal. And so this fits into a lot of this literature that's emerging about place-based effects on life outcomes and economics and health, especially lately. Right now, we're just able to show that in some district, kids have higher academic mobility than others. We don't know if it's the school system is doing something, the neighborhoods, stuff like that. There's future stuff on the plate where we can gain. I think we can learn a little more about that, but it's not ready yet. Okay, and then the last thing we do, we correlate a number of district characteristics with academic mobility. And the two characteristics that really stand out as robust predictors of academic mobility are value added to student achievement, and we do this in a way that there's no mechanical correlation between value added and academic mobility. So, so I think there's something there. And then the socioeconomic status of the student population. And when we look at everything together, it's really the share of the kids who are free lunch eligible that are driving cross-district, that explain cross-district differences in academic mobility. Okay, so now let me get into some of the stuff about what we're doing here. So I want to just give a high-level overview of what academic mobility is and this absolute and relative mobility that we're talking about, and sort of anchored to what we're doing in the paper. So this is what I'll call a rank plot of kids' test scores in two different districts. Each line is a different district. And the horizontal axis is the percentile rank of kids on, say, a third grade test. And the vertical axis would be the percentile rank on the tests in 8th grade for kids, okay? And so the lines here are linear representations of a rank relationship that I'll come back to the linear part in a minute, but they basically tell you how a percentile rank in the 3rd grade maps to a percentile rank in the 8th grade. And so you can see there at the 25th percentile or so on that solid line, the 25th percentile kid in that solid line district is going to have a 8th grade rank of a little over 40%, it looks like, okay? And so you can just read off this line how everyone translates between points in between the test distributions at different points in the career. So the way these lines are drawn, well, sorry, I don't want to say that yet. So we're going to think of absolute mobility as the intercepts on these lines. So if that's the rising tide lifting all boats, a higher intercept is good for everybody. Your total academic mobility is equal to the intercept and then the slope times where you start at, but those intercepts, that's what we're going to call absolute mobility. And then relative mobility is the slope of the line. So the way this stylized example is set, let's see, the solid line district has higher, we're going to say that has higher absolute mobility because the intercept is higher. Technically, you'd read that as the percentile rank of kids who started in the first percentile in that district, but you can imagine that propagating for everybody. You can see it propagates for everybody. And then the solid line district also has higher relative mobility as evidenced by the flatter slope. And so the flatter slope means your outcome in the 8th grade is less tied to your outcome in the 3rd grade, okay? And so what we're gonna do is essentially build a bunch of these rank plots for school districts and use these different measures to understand academic mobility. So that's a pretty stylized example. There is a fair amount of work that has to go into this. A really useful insight from Shetty, Hendren, Klein, and Sayers, who do this for intergenerational economic mobility, is that the rank relationship is functionally linear. When they look at parental and children's earnings, they can see that this relationship is functionally linear. That's true for us too. And so this stylized picture actually works pretty well for documenting academic mobility. And so the appendix to the paper has a bunch of plots that show that. Okay, so that's our framework. So very quickly on the data, we have the 6 states. We have 2 to 4 cohorts in the states, whatever the data would give us. 2006 is the earliest year for most states. There are a couple states we could have gone back further and didn't, just to kind of keep everything consistent. And then 2009 is the latest year we can look at and still track the kids past one year of the on-time high school graduation year, so that we could track that. So you know, a bunch of states, a bunch of kids. The main thing I want to emphasize about this, the data, without getting too hung up on details, there's a lot of heterogeneity across the states. They're quite different in terms of like the racial ethnic composition, the poverty share as measured by the free lunch share, urbanicity, and all that kind of stuff. And just the strong similarity of the results across states, I think, is all the more telling because the states themselves are quite different in many ways. Okay, so I already said we're going to follow students from 3rd grade through high school. We have these 2 test-based metrics. So these are going to be percentile ranks on 8th grade tests, where we're going to take the average rank in math and English language arts. We also set the initial third grade ranks using the average of math and English language arts. And then we're going to have a high school test. The high school test is an English language arts test. The reason we do that is we want it to be given in a consistent grade in the states, because it's going to be confusing to think about mobility if everyone's taking the test in a different grade, and the English language arts curriculum is more structured, so that is doable. For math, everyone's taking the tests at different times. And we have 2 graduation-based mobility metrics, on-time graduation and graduation with 1-year lag. These metrics are conceptually similar, and I'm going to show you the output for them side by side, and the interpretation is essentially the same. We can't rank graduation outcomes, right? Because everyone's either a 0 or a 1, so among all the ones, we can't put them in a rank like we can with test scores. So what the graduation metrics are, say for a kid at the 25th, we're going to say compare 2 districts with kids at the 25th percentile. We're going to say the higher mobility district is the one with a higher conditional graduation likelihood. So if they're 25th percentile kids in the initial 3rd grade distribution graduated at a higher rate, we're going to say that's a higher mobility district. And so that's how we're going to integrate the graduation outcomes into this. I should give a caveat about the graduation results. When you see a district graduating a high rate of initially low achieving kids, you could interpret that optimistically or pessimistically. The optimistic view is they're doing a great job getting these low achieving kids through school. You could also say it reflects low standards, and we can't speak to what it is at this time, but so I just give that as a caveat. Okay, and so then the 2 other kind of wonky details I want to get through before I show the results. We have 2, the first issue is measurement error. So we have measurement error in these tests. We're using the state test to set the initial percentile ranks. State tests are measured with error, and so what that's going to do is that's going to cause some attenuation bias in our estimates. The results I'm showing you today are not corrected for measurement error. We have gone through the full measurement error correction procedure in Missouri, and I can tell you with a high degree of confidence that none of our substantive findings are affected by the measurement error correction. I wouldn't say that lightly, but in Missouri, it's super clear. The appendix shows some of the stuff in Missouri and just how stable, say, like the comparative results are. There are a few estimates that change in absolute terms that I don't think have a ton of substantive meaning, but in terms of like differences by race, ethnicity, and the academic mobility measures, they're not affected by this kind of stuff. And in the revised version, we'll implement the measurement error correction everywhere. The other thing I want to talk about a little bit is sample attrition. So I think we have a pretty great data to do this, to track. So what we're doing is we're following these kids all the way through school, and we have all these great data to do it. But the data aren't perfect, and the big problem we have is we lose kids who leave the states. And these kids are negatively selected, which is just a way of saying that on average, mobile kids have lower outcomes than kids who aren't mobile, and that's true of state movers as well. So there are a couple concerns with this. One is generalizability. So we're going to track academic mobility for kids who stay in these states, and our findings may or may not generalize well to kids who leave the state. I'm not super worried about that. I view that as a modest issue just because most kids stay in the states, and we have so a huge fraction of the sample is covered by our analysis. The bigger issue is the potential for bias. There are two types of biasing issues here. The first is what I'll call reference bias, and so we're going to track mobility for the kids who stay in the state as they go through school. If kids are leaving the state and the kids who are leaving are lower achieving, over time the composition of the comparison pool is getting better, and that's going to mess up our ability to track academic mobility. So we're going to solve that problem in these results. So we have out-migrators leaving all the states, and they're negatively selected. We also have in-migrators. They're negatively selected too. The kids who are switching states just on average are a little bit lower achieving. So we're going to backfill the leavers with the people who are coming into with the kids who are coming into each state, and that solves the reference bias problem. Not perfectly, but I think it does a pretty good job, and there's some other stuff under the hood that suggests that's working pretty well. The other biasing concern is of the more typical variety, that just the kids who are leaving the states are negatively selected in unobserved ways, which could cause some problems with some of the analysis. So for example, one thing we're going to do is look at the cross-district variance in academic mobility. If one district has a lot more state leavers than another, that could create some excess variance that's going to lead us to overstate the variance across districts. For the time being, that's just a caveat. I'm not going to get bogged down in it, but for version 2 of the paper, we have a plan where we're going to do some imputation and try to get a sense of how much this is an issue. Okay. So I'm going to present 3 types of mobility metrics. We're getting very close to just punching through a bunch of charts. Alpha is absolute mobility, beta is relative mobility, and then total mobility, you can measure it at any point in the initial distribution of performance, and we're going to follow Shetty, Hendren, Klein, and Sayes with their work in economic mobility, and just do that at the 25th percentile of the entry distribution. And so this O25 measure is just, it's telling you the percentile ranking of kids who started at the 25th percentile in grade 3 at one of those later outcomes, just alpha plus the slope times 25, and that's going to give you that that total mobility measure. Okay, so here are here's some initial plots. I hope you guys can see these okay in the back. I'm going to try to keep a constant color coding scheme as I'm going to punch through a bunch of different results really fast here, so I'll quickly just lay it out. So blue is, so we're measuring academic mobility for kids. We're starting them all in the 3rd grade and setting those initial ranks, and then we're looking at these 4 different later education outcomes, and those are color coded. So blue is the 8th grade ranks, orange is the high school test ranks, and then we have the graduation and graduation with a lag in gray and yellow. So on the left, I'm showing you beta values. That's the slope of those lines, and these are average statewide estimates. And so starting with the test score betas, so the test score betas are around 0.75 to 0.77. So that's giving you a sense of how anchored, for the test scores, how anchored your test scores are in 8th grade and high school to that 3rd grade test. And so they're pretty heavily anchored. I mean, it depends on your prior. I mean, I wouldn't expect this to be too low, right? These are the same kids. We see them in 3rd grade, we see them in 8th grade. I'm not sure. I guess what you think this is a high or low beta depends on where you started, but in terms of your expectation. But it's around 0.75 to 0.77. When we correct for measurement error, those betas are going to go to about 0.8. And so I think that's like the best estimate of what beta is across the whole sample in terms of the slope of that line. The betas for graduation are not directly comparable to the betas for test scores, and so you shouldn't try to compare those and make sense of that. It'll make your brain hurt. But basically they're much lower. I don't think they're super informative. The reason is for graduation, the line just has to be a lot flatter because most kids graduate. That's all that's really reflecting. I think these 025 values are easier to interpret across the whole sample. So what these 025 values are is telling you the average percentile rank and average graduation likelihood for kids who start at the 25th percentile in third grade on these different outcomes. And so for the test scores, the average percentiles are between the 30th and 33rd percentile or so for grade 8 and high school. And then the graduation rates are a little below 80% on time and a little above 80% with a 1-year lag. After we correct for measurement error, those will go down a tiny bit, but there's nothing substantive that will change. Okay, so that's, I don't know how useful that is. The comparative stuff I think is a little more intuitive for us to look at. So let me get to that. And so first, for what I'm first going to show you is academic mobility differences by student race ethnicity. And so we have Asian, Black, Hispanic, and white students on the left. And so this is all going to be total mobility now. So these are the 025 values for the different kids. On the left is test scores. On the right is graduation. I think the big thing that stands out here is the really high academic mobility for Asian students on both of these metrics. The differences for the other racial ethnic groups are quite small in comparison, actually. But white students do have a little bit higher academic mobility than Hispanic students who have a little higher academic mobility than Black students. The differences are perhaps a little starker in terms of graduation, but on the test scores, they're not that different. But it really is the Asian students that jump out here. By free lunch status, not surprisingly, the kids who are not free lunch eligible have higher academic mobility than the kids who are free lunch eligible. Again, the differences are a little starker when you look at graduation. And then by urbanicity, there are some differences. The kids in the urban areas have slightly lower academic mobility, but the differences are not that large. And perhaps it's surprising that academic mobility for rural kids is very similar to suburban kids. So there's a lot of discussion about rural schools and what limitations they have, but at least in terms of these measures, certainly like in graduation, the rural kids are doing just fine. The biggest differences by urbanicity are for urban kids in terms of graduation outcomes, a little bit lower. Okay, so then I think those patterns I just showed you, I think it's useful to put it in this academic mobility framework, but a lot of that stuff replicates what other folks have found using other types of tools that we have. Here's where we're doing some newer stuff, trying to get a sense of the variation in academic mobility across school districts. And so these are standard deviations of alpha and beta, the intercept and slope, and there's a adjustment that I'm not going to get bogged down in to make these things comparable in magnitude. But what we're trying to do here is get a sense of how much variation there is in academic mobility and where that variation is coming from. And so the first thing I want you to see is that the variation in academic mobility is much higher in terms of absolute mobility, which again is alpha, than relative mobility. So for each mobility outcome we look at, the solid bar is much higher than the patterned bar, whatever that thing is called, which is just telling us that academic mobility, the cross-district variance in academic mobility is much more driven by variance in absolute mobility. What's not shown here is the variance in total mobility. We don't have that available for all the states yet. So part of this is this happens iteratively and we get through some of the stuff, not all of it. What I can tell you from the results we do have in a district that has 1 standard deviation higher academic mobility, the 25th percentile kids are going to score about 5 percentile points better on their tests in higher grades and be 3 to 4.5 percentage points more likely to graduate from high school. So I think that's a pretty significant magnitudes, but of course that's open for discussion. Okay, and then the last thing we do in this paper is we correlate. So then for each district, we produce these total mobility metrics. And then we correlate district characteristics with the mobility metrics. On the left, I'm showing you coefficients from regressions of a district's total mobility measure, this 025 measure, regressed on a bunch of different characteristics. We run the regression separately for each characteristic. And so we'll just one at a time. And so for those of you, I don't know how easy this is to see, but on the left there, we have value added to student achievement. Again, that is a jackknife measure. We don't use any of the same kids for the estimation of value added as we use for academic mobility to at least break any mechanical correlation there. And then we have a bunch of student characteristics, the percent Black, percent Hispanic, percent eligible for free and reduced price lunch, percent on an individualized education plan, percent mobile, and now that's geographic mobility. We should probably be clearer about that. And then we have a school segregation index that we use. So what you can, so I guess let me see here. When you run the regressions one at a time, you see that academic mobility is lower for every characteristic except value added. When you put them all in the regression together, which is on the right, it's really the free lunch share that's driving the negative relationship between academic mobility and student SES. The value-added measures are strongly predictive of academic mobility, regardless of which model you use. We built the value-added measures to work like this, so I won't get it bogged down in the details on that, but that's what was supposed to happen. I will also add that value-added is strongly positively correlated with academic mobility, and that's true for test score measures of academic mobility, but also the graduation measures. Okay, so I think, so a lot of this was getting this framework together and set up for this project. I think academic mobility is a useful way for thinking about how schools go through school and how we might think about achievement gaps and how achievement gaps evolve over time. I think there's a lot of directions to go from here with the project, so I'll quickly give some examples. I don't think I'll talk about all of these. I'll skip the first one. I will say a big step is to try to get a better sense of the whether we can infer causality from any of these estimates, and there's different levels of causality, but a first thing to do might be to look at kids who move districts over the course of the data panels and see if their mobility trajectories change when they move. That might help give us a sense of whether these estimates are actually picking up anything causal. It still doesn't tell us necessarily if it's something about the school or the area, so there's only so far we can get with that, but I think there are some things we can do. Academic mobility can be a useful tool for evaluating the efficacy of different education interventions, the same things we always worry about. You can think about them in terms of affecting academic mobility. And then the other thing I want to be sure to mention is there's this obvious thing, which was an idea we had. We can link our measures of intragenerational academic mobility to the intergenerational economic mobility metrics that Shetty and Hendren and their colleagues have put together. That turns out to be a little bit more challenging than we thought, and so we're working through that right now. And so I will conclude very briefly here. We pull in data from 6 states covering over 2.5 million students to document and understand this idea of academic mobility. Our differences across student groups largely reinforce findings from previous research. There are some modest differences. I didn't get bogged down in it, but for example, our findings for Hispanic wide achievement gaps are a little different than some of the stuff out there in the literature and how those evolve over time. But then the main thing we do is document this variation across districts and academic mobility and at least give an initial sense of what factors are correlated with that. So I'll stop there. Thank you.